ABC is a triangle with A 38 degrees, C 72 degrees, and B 5.82 centimeters. So first we need to do is to draw a diagram. It will give us C is the largest angle here, so 72 degrees C, and A is going to be the smallest angle, 38 degrees A. So this will be B, and then we're given B 5.82 centimeters. Okay, so now in this case, for us to solve for side A, in order for this for us to look for side A, we're going to apply the sine rule, but what we have here doesn't fulfill the sine rule. The condition here doesn't fulfill the sine rule. So how do we make this triangle fulfill the sine rule? For us to be able to use the sine rule states that either two angles and an included side is given, and the side that is given must be opposite to one of the given angles. So this is the side that's given, but the angle it is opposite to is not given. So we need to get that angle. Once we get that angle, then we can use the sine rule, in this case, to get side B. So to get side A. And how do we do that? We do that by saying that angle B is equal to 180 degrees minus 38 degrees plus 72 degrees. What's the reason for doing this? The sum of angles in a triangle. That's the reason. So this will give us 180 degrees minus 38 degrees plus 72 degrees. Let me get my calculator. (110 degrees), and then this will give us 70 degrees. So B is equal to 70 degrees. Now that B is given, we can use the sine rule, because the sine rule states that two angles and a side opposite to one of the angles must be given for us to be able to use the sine rule. So using the sine rule, why are we using the sine rule? So we can get the side A, because actually the sine rule is just a ratio of the side to the angle, or the ratio of the angle to the side. So using the sine rule, now I'm going to say, so basically, let me explain something. The sine rule is A over sine A equal to B over sine B equal to C over sine C, or we could say sine A over A equal to sine B over B equal to sine C over C. So the conditions that must be met is that these are the first condition. Let's call this first condition. Let's call this the second condition. Okay, so for the first condition, two angles A, B, C. Two angles must be given. So let's say this is angle alpha, and this is angle beta, and then this is side A. So either two angles must be given. So one side two angles and the side should be given before we can use the sine rule. Two angles and a side. So once these two angles are given, could be these two or it could be these two, any case, but in this case these two angles are given, then the condition is that the side that was given must be either opposite to this angle or this angle. So if it's opposite this angle, let's say A, then we can use the sine rule. But if it's not opposite this angle, then it must be opposite to this angle beta to B. But if the side given is not opposite any of these angles, opposite this angle or this angle, then we're given this angle, or we're given this side, let's say this side is more or less as C. Then what we need to do is to use this sum of angles in a triangle to get this angle. So once we get this angle, of course, that will not mean that the side given is opposite an angle that is given or that we have gotten, and then we cannot look for to find the other side which also has an angle that is given. So from this rule, what it simply means is that if A and A is given, and then B is also given, then we can look for this side. So we simply have to do the ratio of the side to the angle given equal to the ratio of this side to the angle given. So in this case, it will be the ratio of A, which is the side, over the angle, or to the ratio of the side to the angle equal to ratio of side to angle, side B. So if it is A and C that is given, it will now be the ratio of side A, which is sine A, ratio of sine A to the side A equals the ratio of sine C to the side C. That's all. Therefore, the second condition to be fulfilled, two sides are given. This is 7.1 cm, and maybe this part 6.2 cm. So if two sides are given, for sine rule to be used, one of the angles must be opposite to one of the sides. So if this angle is given, let's say yes, alpha, discover that this alpha is not, the side opposite this angle is not given, so we cannot use the sine rule. Although an included angle is given and two sides are given, we cannot use the sine rule because this angle here does not have a side, and the sine rule is always a ratio of the angle to the side. At least you must know one angle and one side, then you can compare to the angle to the side of the other, or the other angle and the other side. So it's usually the ratio of, or it's usually a ratio of the angle to the side equal to the ratio of the other angle and the other side. So the rule is that one of the angle and the side must be known, sine A over A. Then we can, then at least then the other side, either the angle or the side will be given. So if you are in this case, since this angle is, let's in this case A, B, C, assuming so. Now C does not, the side is not known, but the angle is given. We cannot use the cosine rule since we don't know this angle, we don't know this angle, so we cannot use the sine rule. But if this angle is given, of course, in this case, the opposite angle, let's say this is 20 degrees. Now, this angle, two sides were given and one angle. Which one of the angles must be opposite to one of the given sides? So this angle is opposite to this side. That fulfills the rule. So next thing is to look for sine B. And how do we look for sine B? Since sine B should be the ratio of this angle to this side. So we compare. This one is given. We are going to use the known angle and the side against the known side and the unknown angle. So that's just what it is. So what we do is that since these two sides are known, angle at the side is known. So we say sine A, which is sine 20 over 6.2 against C. We don't know, there's no angle and there's no side, so we don't have anything to do with C. So this known, these two on this side, both the angle and the side is known. So we use this one against this any other side that has at least either an angle or a side. So which one? This one has a side but does not have an angle, so it's going to be sine B over 7.1. So with this, you cross multiply and then you solve. So always take note, ensure that you fulfill the sine rule, then you solve. So in this case, using the sine rule, we've gotten, this was the side that was given to us. In this form, we could not have been able to use the sine rule. So what we had to do was get the angle that's opposite this side, which is and to do that we use the sum of angles in a triangle to get 70 degrees, which is the angle of, which is the value for angle B. Now that we know this side and the opposite angles, we can know here, we can get to know here because we know this angle, or we can get to know here because we know this angle. So we are going to use the known side and angle against either the ratio of one known angle and an unknown side of the other side of the triangle. So using sine ratio, sine B over C. Also, let's, all of the question say we should, A says we should look for the value of side A. So this is A and this is C. So sine A, which is 38 degrees over A, is equal to sine B, which is a known angle, sine 70 degrees over the known side, sine 70 degrees over sine over side which is 5.82. Now, if we didn't ensure that this triangle fulfills the sine rule, now look at the problem we're going to get if we didn't ensure that this triangle fulfills the sine rule. Assuming we just went on with that, what we had there, this triangle, this is 38 degrees, and here is what? This is 72 degrees, and then here's 5.22. And then we're so excited because you've already seen how I proved the sine rule, or actually that sine rule is A over sine A over sine A, B over sine B, C over sine. So of course you cannot use all three at the same time. It's either these two or these two or these two. So it's always two angles and two sides compared to the against one against the other, which that's why you must know one angle and one side. Then for the other ratio, either one angle or the side must be known. But assuming you are using this, look at the problem you are going to get. You didn't do this. You didn't ensure that you know side B, which must fulfill the sine rule. So assuming you just want to put this into this formula because you feel since it does not fulfill the cosine rule as it is, then it must fulfill the sine rule. Then you put this into the formula. Look at the formula you're going to get. Sine B. So you're going to compare sine A and sine B. This is sine A. Sine A is 38 degrees over no side, that's A, equal to now B, which is given to which we have this the side opposite angle B is known, so sine B is unknown. Sine B is equal to 5.32, and then sine C is also unknown. Sine 72, sine C, the angle is known, sine 72 degrees over C. Now look at it. You cannot use this theory as it is. So what you do is either you use this ratio against this ratio, or this ratio with this ratio, or this ratio with this ratio. So in either case, if you use this sine 38 degrees over A is equal to sine B over 5.32. You now see the problem. You have two unknowns to work for, and in maths you can't work for two unknowns at the same time. How can you solve for sine B and sine and A in the same equation like this? Because you must at least know either this angle and solve for A, or you must know sine A to be able to solve for sine B. But if this is what you get, of course you can't, there's nothing you can do. That means something is wrong somewhere. You are not following the right process. Then if you are not comparing this to this, assuming you want to work with these two, you still going to meet the same problem. You have B unknown and C unknown. So you have two unknowns to work for in the same equation, and it's not possible. Or if you decide to compare this to this, that means you have sine 38 degrees over A equals to sine 72 degrees over C. Same problem, two unknowns. So you see why it's very important to follow the process and make sure you understand why I was making emphasis on this, ensuring that you fulfill the sine rule. Because for this not to occur, you must know one angle and the side opposite angle at that angle, and then either a side or an angle of the other side of the triangle must be known, so that the ratio can, then at the end of the day you only have one unknown to work for, which in this case sine 38 degrees, 70 degrees and 5.8. So we only have A to work for. So let's proceed with what we have on the board. The sine 38 degrees over A is equal to sine 70 degrees over 5.82. So next is to cross multiply. This means this will multiply this and this will multiply this. So this will give us 5.82 sine 38 degrees equal to A sine 70 degrees. And we're going to divide both sides by sine 70 degrees in order to make A the subject of the formula. So A is equal to 5.82 sine 38 degrees over sine 70 degrees. A is equal to 5.82 times value of sine 38 will give us 0. I'm going to round approximate to the nearest four decimal places, 6157 over sine 70 degrees, 0.93 97. Well, you could just go on with 5.8 to sine 38 degrees. Just punch to the calculator to give you the value straight away, rather than writing the value for sine 38 degrees out and that of sine 70 degrees out before going on with the process. So this will give us A is equal to 5.82 times 0.66157. That's 3.5374 over 0.9397. A is equal to 0.9397, 3.8133. Okay, so we're going to let's approximate to two decimal places. A approximately is equal to 3.81. What's the unit? Centimeters to 2 dp. So that's the value of A, 3.81 centimeters to 2 dp. So let's get the value of B. So this is for A. B is also using sine rule, because now the condition is fulfilled. We already know angle B and it's the side B. So if you use sine rule to get C, this angle is known, and then we can get to know C. So using sine rule, we have to compare sine B, which is the known angle, and the known side. Sine B over B is equal to, now this for C, angle is known and the side is not known, so and the sine C over C. Now let's put the values. So sine B is 70 degrees, sine 70 degrees over the side 5.82 is equal to sine C, sine 72 degrees over C. And when we cross multiply, we're going to have sine 70 degrees C sine 70 degrees is equal to 5.82 sine 72 degrees. So C will give us 5.82 sine 72 degrees over sine 70 degrees, and this will give us, so C is equal to 5.82 sine 72, 5.82 sine 72 degrees is equal to 5.5351 divided by sine 70 degrees. That will give us 5.890, 5.8903 approximately. So side C approximately is 5.89 centimeters to 2 dp. So therefore angle B is equal to 72 degrees and A is equal to 3.81 centimeters, and C is equal to 5.89 centimeters. Alternatively, we can use logarithm tables to get the values of this. So for A, we must start from here. So to get a value for A is equal to 5.82 sine 38 degrees over sine 70 degrees. So you write here number, you write here log. So for 5.82, and then here we have sine 38 degrees. So the logarithm, I'm going to get another table. So from logarithm table, our characteristic here will be 0.58 under 2. 58 under 2 will give me 7649. 7649. Now for this part, sine 38 degrees, don't use your calculator, you're going to use your table. So you're going to, there's in your four-figure table, you're going to have a part that says logarithm of sines of numbers. So each of them has logarithms of tangents of angles is there. You have logarithms of cosines of angles and logarithms of sines of angles. So locate logarithms of sines of angles. Don't just punch sine 38 on your calculator or log sine 38. Use your table. So what's logarithms of sines of angles? So sine 38, just look for, go under where you have x, look for 38 and go under 0.0 because you don't have 38 points anything, so you just 38. So under 0.0 look for the value of 38. 38 is bar 1.7893, bar 1.7893. So now we're going to, from our logarithm, you know that when the numerator there's multiplication, the numerator you add, and then when there's division you subtract. So let's add this part in the numerator first of all. The 9 plus 3 will give us 12. 4 plus 9 will give us 13, plus 1 14. 6 plus 8 is 14. 7 plus 7 is 14, plus 1 15 points. Now here is 0. What that implies, remember we have a carried over, so here is 0. So 0 plus the carried over 1, and then this bar 1 means minus 1. So 0 plus 1 is 1, 1 minus 1 is 0. Now here is supposed to be 5. 4 plus 9, 13, plus 1 carried over from me, 14. So 6 plus 8, 14, plus 1, 5, 5, 5, 4, 2. So this is for the numerator. The next one we are going to look at is the denominator, which is sine 70 degrees. Sine 70 degrees. So for sine 70 degrees, still under logarithms of sines of angles, because we are looking at sine 70 degrees, check 70 under 0.0. So 70 bar 1.9730, bar 1.9730. So you're going to subtract the denominator from the value of the denominator from the value of the numerator. So this is the value of the numerator, add this to the denominator. Just put minus here. Then you try draw this way. 2 minus 0 is 2. 4 minus 3 is 1. 5 minus 7 no point, you can't subtract 7 from 5, so you have to borrow from here. So when you borrow from here, the one you're borrowing from here, you join it to 5, it becomes 15. 15 minus 7 will give us 8. So remember, now here is 4 because you borrowed one from here. So 4 minus 9, it's not possible to remove 9 from 4. So what you need to do is to come here. Though here is nothing, here is 0, but in math it's not, 0 does not mean nothing in this case under logarithm. So what you do is that you can borrow from this. So when you borrow from here, this 0 will become minus 1, and that 1 that you borrow from here, if you join it to 5, it becomes 15. 14 minus 9 will give us 5 points. So here minus 1, bar 1 minus bar 1. And remember that bar means minus 1 minus 1. So minus times minus will give us plus, minus 1 plus 1. So minus 1 plus 1 is 0. So here is 0. So the next thing we're going to do is to look for the anti-log of these numbers. And to look for the anti-log, go to the four-figure table, or you can punch your calculator 0 point. Just put in your calculator, you can press shift, then log. It will give you anti-log function. Once you do this shift log, then you put this number 0.5812 to give you the value straight away. Okay. Then, but let's use the four-figure table. So for the four-figure table anti-log, you have a way that is designated. On the x column, you have x column like this. You have 0.00, 0.01. So let's say 0.20 down to 20.21, like that. So which means that in your anti-log, the first two decimal numbers are what you are going to have on the x column, and then this one will be under the number here 1, 2, 3, 4. So you locate this under any of this. Here, this number ranges from 1 to 9, and then this fourth number is gotten from the difference column. So you locate 2 under the difference column. So what it implies that 58 under, so 0.58. So when you're going for 0.58 under 1, so come in 1.58 under 1, whatever the value is, then go to difference 2. In the difference column, go to difference 2, 1, 2. Then go to trace it to 58.58, difference 2, whatever the value is, you add it to this value. So 0.58 under 1 will give us, until log into numbers, 0.58, 0.58 under 1, 3811, that's 3811, difference 2, 58 under 1, difference 2, difference 2 is 2, and that, so you add together, this 1 plus 2 is 3, 1, 8, 3, that's 38, 1, 3. Now this is not the final answer. Since your characteristic here is 0, this means that move your decimal points 1 place forward. So this will give us 3.813. To understand logarithms better, you can check the video on logarithms in the channel. Check the video on logarithms, and it will clear any doubts or any misunderstanding you have, especially this negative values you're seeing here. So these are final answer. This is the anti-log of this. So if you punch your calculator, shift log, just press shift first for the log, and put this value 0.5812. The calculator will give you 3.813 on and on as a final. So when you approximate, you're going to have 3.81 centimeters to 2 dp. So when we approximate this to 2 dp, we're going to have 3.81 centimeters to 2 dp, which is exactly what we have here. So that's the alternative for this. So you can also do the same. Here, and discover that your final answer is 5.89 centimeters. So first, draw a sketch of the diagram. First, draw a sketch. A sketch of the diagram. In triangle ABC, B is 39 degrees, C is 82 degrees. So apparently C should be larger than B. So let's draw our diagram. Okay, so what I'm saying, this part seems larger. So this will give us 82 degrees. Another factor you need to notice that the larger angle is opposite the largest angle is opposite to the largest side or the longest side, and the smallest angle is opposite to the smallest side. So if this is the largest angle, assuming it is 2 degrees, so this is C, and then D is 39. So let's say that this is the smallest angle, 39 degrees B. So, and we are not giving value for the side C. A, which was given to be 6.73 centimeters. If we proceed this way, we're going to get to a point where we would not be able to go on with our solution. So assuming we've started like this, sine A, because let's say these two angles are given, so sine A, also this side is given sine A over 6.73 equals sine C. Sine C is 82 degrees, sine 82 degrees over C, sine B, sine 39 degrees over B. So you see, if we compare this to this, we have this A as an unknown, we have C as an unknown. And if we compare, if you use this, equate this and this together, A is unknown, B is unknown. If we equate these two together, C is unknown, B is unknown. So you see the problem. So what do? We follow this as it is, doesn't fulfill sine condition for us to use the sine rule. So for us to use the sine rule, we must ensure that we know at least. So since two angles are given, then the sine rule says two angles and a side, and that side that is given must be opposite to one of the angles that is given. So the side given here is not opposite to this angle, is opposite to this angle, but the angle that is opposite to is not known. So how do we know this angle? For us to be able to use the sine rule, we use, so say A is equal to 180 degrees minus 39 degrees plus 82 degrees. Now what's the reason? Sum of angles in triangle. Sum of angles in a triangle. Always state your reason when you are solving or calculating. Always state your reason. Don't assume, state it. So 180 degrees minus 39 degrees plus 82 degrees. So A is equal to 180 degrees minus 39 plus 82. That's 121. 121 degrees. And that is 59 degrees. So now that we've known angle A and we know the side, we can get either side C or side B, because at least an angle is known, an angle side B, angle B is known, and angle C is known. So what's left is to know either B or C. So what does the question say? The question says we should look for C, which is the side C. So we are going to compare. We're going to use the ratio of the known angle and the known side against the ratio of either a known angle and an unknown side, or a known side and an unknown angle. So using sine rule, let's come here. Using sine rule, we are going to use, first of all, the side that's known, both the angle and the side that are known. So in this case, angle A and the side A is known. So this is sine A is equal to A, and what are we looking for? Side C. So to be the ratio of sine C over C, now we use sine C over C. And so let's put the formula sine. Let's put the values. Sine A is equal to sine 59 degrees over A, which is 6.73. 6.73, which is equal to sine C, sine 82 degrees. Sine 82 degrees over C, which is what we are looking for. So we cross multiply. When we do that, we have 6.73 sine 82 degrees over sine 59 degrees. And that will give us 6.73 times sine 82 divided by sine 59. That is 7.7750. 7.7750. So if you approximate, so this will give us 7.78 centimeters to 2 dp. So QRS is a triangle with QS equal to 12 meters. Angle RQS is equal to 30 degrees, and angle QRS is equal to 45 degrees. Calculate the length RS. Now, the first thing is to draw a sketch of the diagram. We can have something like this. So QRS, QRS. Now, for you to understand this notation, there are two different ways to represent angles. QRS equal to 45 degrees and RQS equal to 30 degrees. Now what this implies is that usually angle QRS means that the angle is at this middle letter. So in your diagram, it is PQR. So for angle QRS, the angle is R, so 45 degrees, that means 45 degrees. So the middle letter is Q. That's Q is 30 degrees. So that's the way. The another way to represent it, that we're using this notation, this symbol, we can simply say Q angle RS equals to 45 degrees. So when you see this on top of above a letter, it means that when you draw the triangle, the position you place that letter, you put this angle here. So with this notation, if I draw my triangle this way, when I draw it this way, and instead of having Q here, let's say I have R here, and then it's a P. No, let's say this is S, and then let's say this is P. So P R S. Okay, P Q R. So this is, let's say this is R. So R Q angle RS is equal to 45. So these signs are both letter R, so they'll be 45, and then the R angle QS is equal to 30 degrees. So since these signs are both, the angle signs are both Q, it means it's going to be, so let's say SQ, it will be 30 degrees. So take note of that. So R angle QS is equal to 30 degrees. Yes, 30 degrees. And Q angle RS is equal to 45 degrees. So angle RS 45 degrees. 45 degrees. And we're given the side QS with 12 meters. QS 12 meters. So let's see, it fulfills the sine rule. So these two angles and one side, and the side given is opposite one of the angles that is given, so it fulfills the sine rule. So the question says we should calculate the length RS. So we're going to look for this side. So we're going to say using sine rule, sine R over 12 is equal to sine Q over RS, where the side facing sine Q is RS. So RS, making RS the subject of the formula, we have sine R is equal to 45 degrees, and sine Q is equal to 30 degrees. Okay, so RS is equal to, when we cross multiply, when we make RS the subject of the formula, we're going to have 12 sine 30 degrees over sine 45 degrees. This will give us 12 sine 30 degrees divided by sine 45 degrees. 8.485, 8.4853, which approximately is equal to 8.49 centimeters to 2 dp. You can approximate to the nearest whole number or to any number of decimal places you want, but this one is my choice. Or alternatively, we can say, if your final answer is in solid form, that means since these are special angles, they didn't use the values for each of the angles, rather it was special angles that was used. So alternatively, sine 45 degrees over 12 is equal to sine 30 degrees over RS. So RS is equal to 12 sine 30 degrees over sine 45 degrees. But from special angles, sine 30 degrees is equal to 1 over 2, and sine 45 degrees is equal to 1 over root 2, which is, when you rationalize the denominator, you will have root 2 over 2. So let's put this into the function here. So sine 45 degrees, so RS is equal to 12 times sine 30 degrees is 1 over 2, 12 times 1 over 2 over sine 45 degrees root 2 over 2. So we can say 12 times 1 over 2 times 2 over root 2. Okay, a little bit too fast. Divided by this sign, this is division, so divided by root 2 over 2. So 12 times 1 over 2. Change this sign to multiplication and invert 2 over root 2. And of course, this will give us 12 times 1 over 2 times. When we rationalize it in the middle, we have 2 root 2 over 2. 2 here, 1, 2 here, 1, 2 here, 1, 2 here. 6 plus 6 root 2. 6 root 2 meters. So in short form, in case your answer is in short form, that's the better way to use the answer rather than this way. So if you punch your calculator 6 root 2, you get this back in your calculator. Given that the two angles of a triangle are 30 degrees and the longest side is 10 centimeters, calculate the length of each of the other sides. Okay, so let's draw a triangle. Since the two angles are 30 degrees each, that seems to be like an isosceles triangle. These angles are equal 30 degrees, 30 degrees. So let's say this is A, B, C. We're not giving any log later, so I'll choose to use triangle ABC. So we don't know A, we're giving one of the sides, and the longest side is, so if this 30 degrees is 30 degrees, this should be the largest angle. So of course the longest side should be opposite the largest angle. That's 10 meters. So this does not fulfill sine rule, because for sine rule, the side given must be opposite the angle, one of the angles that is given. So this side is not, the angle here is not known. So for us to fulfill sine rule, we must get to know A. So A is equal to 180 degrees minus 30 degrees plus 30 degrees, raising sum of angles in triangle. Okay, so this gives us 180 degrees minus 30 degrees plus 30 degrees will give us 60 degrees. That was 120 degrees, so which even justifies why here's the largest side. But the angle is at 120, so it's the largest angle of, so for any triangle, the largest sides opposite the largest angle, and so also the smallest sides opposite the smallest angle. So the question says, given that the two angles of the triangle are 30 degrees and the longest side is 10, calculate the length of each of the other side. Since the two angles are the same, which means the two lengths will also be the same. The length of this side will be the same, will be equal to the length of this side, since the angle here is equal to the angle here. So using sine rule, now that it fulfills the condition for using the sine rule, using sine rule, so we're going to get the ratio of the known angle and the known side first, which is sine A. Sine A over A is equal to either this or this. So this is C and this is D. Sine B, let's use sine B over B. So sine 120 degrees over 10 is equal to sine 30 degrees over B. So B sine 120 degrees is equal to 10 sine 30 degrees. And of course, 10 sine 30 degrees. So B is equal to 10 sine 30 degrees over sine 120 degrees. And so B is equal to 10 sine 5 divided by sine 120, 5.7, 5.7705. So B is equal to the nearest one decimal place 5.18. B is approximately 5.821 BP. That's the value for B. Now, since B is the angle C is equal to angle B, it's also, and the question says we should look for the length of each of the other sides. So since, therefore, okay, let's say, since angle B is equal to angle C, it implies that, okay, it implies that the side B is equal to C. Therefore, C is also equal to 5.8, 5.7725, and C is also equal to 5, approximately 5.8 to 1 dp. In an acute angled triangle, PQR, where PQ is equal to 10 meters, PR 15 meters, P angle RQ. So angle R is 40 degrees. Let's say 40 R P Q. PQ is 10 meters. PR is 15 meters. Evaluate angle PQR. So we're going to look for angle Q. So this fulfills sine rule, two sides and one angle, of which one of the sides that's given is opposite to one of the angles, opposite to the angles given, rather, but it's only one angle that's given. So two sides and one angle, and the angle is opposite to a given side. So sine rule is fulfilled. So using sine rule, so the ratio of the angle to the side that's known. So sine R over R is equal to, and then the ratio of the side, the ratio of the angle that's known to the side that's known, sine Q over Q. Okay, so let's put the value. Sine R is equal to sine 40 degrees over 10, and then sine Q is unknown, and then the side is 15. So 15 sine 40 degrees is equal to 10 sine Q. Sine Q is equal to 15 sine 40 degrees over 10. This is equal to 15 sine 40 divided by 10, 0.9642. This is sine Q equal to 0.9642. Of course, this will give us, so Q, divide both sides by sine, that will give us arc sine. As the reciprocal of sine, arc sine, 0.9642. And then Q is equal to, so in your calculator, just press shift, then sine function, then put this figure 0.9642 to give you the value for the angle that's equivalent to 0.9642 in sine. So shift sine 0.9642, 74.6226. So to the nearest, Q is equal to 74.6 degrees to the nearest place. But if I approximate to the nearest degree, so Q is approximately 75 degrees to the nearest degree, which is also the nearest whole number.